This review goes over every part of transformation. So these first few questions go over a reflection. So the first one says PQRS has vertices 1, 2, 2, 5, 8, 3, and 7, 0. So you want to start by graphing that. So once you get that graphed, it should look like this. And then we're reflecting over the line y equals -1. So that's actually this horizontal line right here. When you reflect over this line, you're just counting the distance to the line and then counting the same distance over it. So for example, S is 1 away from the line. So we want to go 1 over the line. So we're going to put S prime right here. R is 1, 2, 3, 4. So we want to count down 1, 2, 3, 4. Here's R prime. Q is 1, 2, 3, 4, 5, 6. So again, 1, 2, 3, 4, 5, 6. And lastly, P is 1, 2, 3 away. So 1, 2, 3. P prime would end up right here. Then you want to fill in your ordered pairs. So P prime is at 1, -4. Q prime is at 2, -7. R prime is 8, -5. And S prime is 7, -2. Number 2 starts off the same way, so we're going to start by graphing our figure. After we graph it, we're going to draw in our line, which is x equals 1, which is a vertical line here. And then we're going to count to the line and over the line. So J is actually going to stay right where it is because it's on the line, so it's not going to be moving. K is 1 away, so we're also going to go 1 over, and here's K prime. And then L is 1, 2 away, so we're going to go 1, 2 over the line for L prime. Writing down our ordered pairs, we have 1, -1, 0, 3, and -1, -2. Example 3 and 4 are really similar, so check out the PDF answer key if you want to check your answers for those. To dilate by 3 using center 1, -2, we're going to start by graphing the point -1, -2. So that point is right here. I like to label my points on my triangle, so I'm going to call this triangle ABC. And what you want to do is you want to count directions from your center to each point. For example, from my center to point A, I'm going down 1, right 1. So I like to just write myself directions. From my center to my point B, I'm going down 1, right 1, 2, 3. And then from my center to point C, I'm going down 1, 2, 3, right 1, 2, 3. Since I'm dilating by 3, I'm going to go through and I'm going to multiply all these directions by 3. So for A, I'm now really going down 3, right 3. For B, I'm actually going down 3, right 9. And for C, I'm really going down 9, right 9. Once I get those written down, I'm going to go ahead and count my new directions. So I'm going to go back to my center point, and for A, I'm counting down 3, so 1, 2, 3. And I'm going to the right 3, 1, 2, 3. So point A is really going to end up right on top of C. For point B, I'm going down 3, right 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's where point B prime ends up. And then lastly, again, I'm going back to the center. I'm going down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's C prime. And so my new shape ends up right here. Number 6 is very similar. So I'm going to start by plotting my center, which is at 1, 1. So right here. I'm going to start by counting from my center to point A. So I'm going up 1, 2, 3, 4. Left 1, 2, 3, 4. Then I'm going to count to B, so I'm going up 1, 2, left 1, 2, 3, 4, 5. And then for C, I'm going down 1, 2, 3, 4, 5, 6, and right 1, 2, 3, 4. Since I'm dilating by 1/2, I'm going to take each of these numbers and multiply them by 1/2. So for A prime, I'm going to be going up 2, left 2. For B prime, I'm going to be going up 1, left 2.5. And for C prime, I'm going to be going down 3, right 2. So again, I'm going back to my center. For A, I'm going up 2, 1, 2, left 2, 1, 2. Here's my new A. For B prime, I'm going up 2, back 2.5. So, I'm going up 1, back 2.5. 1, 2.5. Here's B prime. And then for C, I'm going down 3, 1, 2, 3, right 2, 1, 2. Here's C prime. When I connect, here's my new triangle. Seven and 8 are very similar to 5 and 6, so I'm going to go ahead and skip those. You can check the PDF for the answer. If you want to rotate a point, the 90-degree rotation rule is -y(x), which means we're going to flip spats and change the first sign. So for example, if I'm starting with -5, -2, -2, -5 is switching spots, and then making the first one, the -2, positive, will change the sign. If I want to do 180, I'm just going to do another 90-degree rotation to get there. So again, I'm going to switch their spots, -5, +2, and I'm going to change this first sign. So now it's +5, +2. If I want to do 270, I'm going to take the 180 and I'm going to do one more 90-degree rotation. So again, switch their spots. So now it's 2.5. Change the first sign. So it's -2.5. For 10, we're dilating. So the first time we dilate, I'm using point A. I'm going to go ahead and multiply by 1/2. So I get -2, +1. The second dilation tells me, okay, this time go ahead and use 2. So I'm going to do times 2 times 2. I get -8, +4. For this next one, it wants me to use each reflection rule to reflect the point. So y equals -x is -y, -x, which really means switch their spots and change both signs. So if I originally have 1, 8, 8, 1 would be me flipping spots, and making them both negative would be changing signs. Since right here I still have a prime and not a double prime, this means they want me to use the very original point. So I'm going to go ahead and use this point up here, 1, 8, every single time I do this for a new rule. For reflecting over y equals x, the rule is yx. So you keep the signs the same, but you just switch their spots. So instead of 1, 8, I have 8, 1. The rule for the x-axis is they stay where they are, but the y-intercept is going to change signs. So instead of 1, 8, I'm going to have 1, -8. And then for the y-axis, they're going to stay where they are, but the x-coordinate's going to change sign. So instead of 1, 8, I'm going to have -1, 8. For a translation, you literally just read what it says and do the math. So if our point is 1, 8, the rule says x minus 2. So I take the x-coordinate, I subtract 2, and then y plus 4, I take the y-coordinate and I add 4. So my new point is really going to be 1 minus 2, which is -1, 8 plus 4, which is 12. 13 and 14 are a composition, which just means do a bunch of transformations in a row. Notice that the first time we do a transformation, it's called A prime. The second time we do it, it's called A double prime. This means that when I do my second rule, I should be using this point here instead of the original. So let me show you what that looks like. So up here we have A, the original point is -3, +6. We're doing a reflection over the line y equals -x, which means switch their spot and change their sign. So I'm going to switch their spot, and I get 6, -3, and then I need to change both signs, so now I have -6, +3. When I do the second step, dilating using a scale factor of 1/3, I need to use this -6, +3, this first transformation that I got. So I multiply both of those by 1/3. So -6 times 1/3 is -2, and 3 times 1/3 is 1. Same thing here. When I'm rotating 180, I need to use this double prime point. When I rotate 90 degrees using the rule -yx, I'm going to get -1, -2. But I'm not done. Since I'm doing 180, I need to take this point and rotate it one more time. That's going to get me to -1. And then lastly, when I do this translation, again, I'm using this triple prime to get to this quadruple prime. So it says take the x and subtract 4, which gets me -2. Take the y and add 8, and I get 7. 14 is really similar, so I'm going to go ahead and skip that one. Number 15 is dilating a line. You want to start by graphing your original line. We graph a line by starting with the y-intercept, which is this number that's on the end that's not with x.
Good evening.
So I'm going to go down 4, and then I'm going to use my slope, which is 3. I'm going to go up 3, right 1, up 3, right 1, and then I'm going to make a line. Since it doesn't tell us the center, we can assume it's at 0, 0. You want to count some directions to the nearest point. So I'm going to go ahead and just count straight down 1, 2, 3, 4 to the y-intercept. So I'm going down 4. Since it says dilate by 2, I'm going to multiply that by 2. So instead, I should really be going down 8. So I start at my point, my center, 0, 0, and I go down 8. Then to get the rest of the points on the line, I use my original slope, which is 3. So I'm going up 3, right 1, up 3, right 1. So here's my new line. To finish it off, I have to write the equation of that line. So the slope stays the exact same, and the only thing that's changing is the y-intercept, which is down 8. So it's -8. Number 16 is very similar. Check out the answer key that's posted online for that one. For number 16, it says triangle ABC is transformed to create triangle PQR. Which of the following transformations would maintain congruency of the two triangles? The only transformation that changes the shape at all, making it a different size, is a dilation. So that's the only one that's going to make them not congruent. A translation, a rotation, and a reflection is moving them around the graph, but it keeps them the same size and shape. For 19, we're going to start by graphing the pre-image. Once that's done, we're going to start using our rules. So it says translate the figure. So we're going to subtract 1 from each x and add 2 to each y. So for A prime, I'm going to get 0, 0. For B prime, I'm going to get 6, -1. And for C prime, I'm going to get 5, -5. When I reflect over the line y equals x, I'm using the rule yx. So they're switching spots. So I still have 0, 0. Now I have -1, +6, and now I have -5, +5. If I'm rotating 90 degrees clockwise, this is actually doing a rotation that's 270 counterclockwise. So I'm just going to pick one of my points, and I'm not going to use 0, 0 because nothing's going to change there. So I'm going to use B double prime. So the original point, B double prime, is -1, 6. When I rotate it 90 degrees, it becomes -6, -1. When I rotate it 180, it becomes 1, -6. When I rotate it 270, it becomes +6, +1. And then I'm just going to kind of compare so that I don't have to do all 3 of those all over again. So if I look here and here, what I'm noticing is they switch spots, and then the second coordinate changed sign. So same thing up top, I'm gonna switch their spots, and then I'm gonna make this one positive to change signs. And then I'm gonna graph this final figure. This last one I'm gonna do in a bunch of different colors. So it asks what would carry this figure onto itself. So I normally just pick one point to start with and see if things work out. So I'm gonna start with this point I just drew over in red. So it says reflect over the y-axis, which would put this point here. Rotate 90 degrees. So if that's 1, 1, it's gonna become negative 1, 1. So it's actually gonna end up back where it was to begin with. Lastly, it says reflect over the x-axis. So now it ends up here. And that is definitely not on itself. So this is a no. I'm going to repeat the process. So this time I'm going to use blue. I'm going to start with the same point. So reflect over the y-axis, that puts me over here. Rotate 270. So again, I start with 1, 1, and then this is 90, this is 180, this is 270. So 1, negative 1, now I'm right here. Then it says reflection over the x-axis, which just brings me right back here, and that's not on top of itself. So let's try again. This time I'm going to use green. Again, I'm going to start with this point. Over the y-axis puts me right here. If I rotate 180, I have negative 1, 1, and then negative 1, negative 1. So now I'm over here. And then if I reflect over the x-axis, that brings me back up top. So it's looking like this one's going to work out. And then very last attempt, I'm going to do in yellow. So again, starting here, if I reflect over the x-axis, I end up down here. If I rotate 90, so originally I'm at negative 1, negative 1. When I rotate 90 degrees, I end up at 1, negative 1, which is down here. And then lastly, reflecting over the x-axis puts me right here, and that's a no. The last page of the answer key you can check out in the PDF. There's not a lot of explanation that goes into it. It's just knowing your rules and having them memorized. Make sure you work on memorizing your rules tonight. That way things go smoothly for your test tomorrow.